Gas chromatography is superior to thin layer chromatography in many ways. Particularly, it's much more sensitive and it gives much higher resolution than the very simple TLC plates. There are many technical differences between the two methods, even though they rely on the same physical principles. For a start, in gas chromatography, as you might be able to figure out from the name, the mobile phase is not a liquid, it's a gas, often referred to as the carrier gas. In addition, gas chromatography does not use a plate. It uses something called a column as the container for the stationary phase. Now, even though it's called a column, it doesn't actually look like a column. The name is retained for historical reasons. The stationary phase is packed inside a very long, fine metal tube. And for reasons of space, that metal tube is wrapped around in a coil inside the instrument. So one end of the coil is where the material goes in. At the far end of the coil, the material comes out, and then it passes to a detector, and the signal from the detector is then recorded by a computer. So here is another technical difference between TLC and GC. In TLC, we were allowing the mobile phase to move a certain distance, and then we measure the distance moved by the components. That is, the distance moved by the components within a fixed time. In GC, it's different. Because the distance moved by the components is fixed, it's the length of the column. So what we are measuring is the time it takes the different components to get to the end of the column. So we cannot use the RF, the retention factor, that we did in TLC. Instead, we use the retention time. That is the time for that component to travel through the column. So the output, the data that we get from the GC, looks a little bit like this. We no longer have spots on a plate, we have peaks on a graph. And we're no longer measuring RF, we're measuring the retention time, and this is typically measured in minutes. But the principles are the same. When we get peaks from our GC, from our unknown sample, we can then do a tentative identification by comparing them to known standards. So if your unknown material comes off at a particular time, your standard comes off at that same time, then tentatively we can say that is the compound. Though just like with TLC, it's not a very firm identification. There is another technical difference between GC and TLC. And that is your GC chromatogram will always show a big peak after a very short time. And this peak we always ignore because it is solvent. To inject your sample onto the GC, you have to dissolve it in a solvent. You have to make it into a solution. So of course the solvent will also be picked up by the detector. But the solvent will come through the GC column very quickly, and it's this big peak you see at about 1 minute or so. Now, the sophistication of GC gives it yet another advantage over TLC, and that is GC is quantifiable. With TLC, when you see a spot, you cannot say much about the quantity present from that spot. But with GC, the amount of material present is proportional to the area under the peak. So not only can we separate out a mixture into its different components, we can also measure the relative amount of those components that are present. So GC is a technique where we can quantify the components. This is a gas chromatograph, or GC, and this one is fitted with an auto sampler so that it can run multiple samples one by one. with the autosampler, which is effectively an injection robot. The sample is injected into the instrument automatically by this syringe here. The column where the components of the mixture are separated is inside this oven. The oven temperature is programmable. It can be completely controlled. And the column, which is many meters long, is wrapped around here in this coil. The output from the column goes into the detector, which is built into the top of the machine here. The information from the detector then goes onto the computer, where it can be displayed and recorded. The other chromatographic technique that is very important for forensic science is HPLC. The initials HPLC stand for High Performance Liquid Chromatography. They also stand for High Pressure Liquid Chromatography. Now, HPLC is similar to GC, but as the name implies, the mobile phase is a liquid, not a gas. And the mobile phases used are organic solvents or sometimes aqueous solutions, depending on what you're trying to analyze. HPLC does not use the very long, fine metal tube to contain the stationary phase that GC used. HPLC, we use steel columns, and we have to use these steel columns because of the high pressures involved. Why do we use high pressure? Because the stationary phase is a very fine material densely packed inside the column. So to get the liquids to flow through the column at a useful rate, we have to apply a high pressure, and that is done with a pump. So we need the high pressure to get the good flow rates, and therefore we need the steel columns to have the strength to stand up to those pressures. Like GC, with HPLC, we are measuring the time it takes for each individual component to get from one end of the column to the other end of the column. So once again, we are measuring retention times. So the output, the data that you get from an HPLC, the chromatogram, does look rather like the chromatogram that you get from a GC, with these sharp peaks appearing, one for each component. And you can see from this chromatogram that HPLC tends to give well-resolved, sharp peaks, so you can easily separate and resolve many different compounds. Just like GC, HPLC can also be quantified. So the area under the peak for a particular component, once again, is proportional to the amount of that component present in the mixture. Okay, this is an HPLC instrument. On the top here, we have the different components that mix together to make the mobile phase in these bottles. Here we have the pump that pumps the mobile phase through the instrument and provides the pressure. The sample is injected into the system, once again by an autosampler. It then travels along this very fine tube here to this part of the instrument, and here we have the column. And you can see the HPLC column is quite different to the GC column. This is made of steel, and the pressure inside is currently 157 bar. The sample passes through the column and then passes to the detector, and the information from the detector is fed to the computer, and again it can be displayed and recorded. So which is better, HPLC or GC? Both methods are very efficient, they're very selective, they can resolve a great number of compounds, and both of them are widely applicable. In both cases, the detectors are very sensitive, so you only need very small amounts of sample in order to complete the analysis. They may be non-destructive of the sample, meaning that after the chromatography, you can get your sample back, though in practice, This is very, very rarely done. Both methods are quantitative. Okay, with both methods, you can measure the amount of each component that is present in the mixture. And both methods work with high resolution. There are some differences. Okay, GC has the advantage that the equipment is a little simpler and it tends to be a little less expensive than HPLC, and oftentimes GC is also faster than HPLC. HPLC, on the other hand, has the advantage that it can be used for samples that are non-volatile and also for samples that are thermally unstable. But both methods are very, very widely used for the analysis of compounds.